In this section we will download Git, install and then configure it for further operation. Essentially, Git is a fairly simple tool to install and doesn't require almost any additional pre-installed software. Unlike an integrated development environment such as Eclipse or IntelliJ IDEA, you won't need to install a JDK or define some environment variables. You simply download and install. Let's see how we can do that. We go to gitscm.com and right over here we select Release. All of my following examples will be for Windows. If you're using Linux, in reality it's even easier, but I suspect that Linux users will be able to figure out the installation process quite quickly using the apt-get or another built-in package management component. Thus, we simply download the most recent version for Windows. This is what it looks like, and we take a look inside. Okay, next. Here are some remainings of old Git. You shouldn't have anything like that. So I'm basically clicking next, I'm not changing any of the settings, so the installation should be pretty simple. Okay. Fundamentally, Git is a tool for Linux, so it installs a type of shell that will allow us, working from within the Windows operating system, use the Linux commands such as SSH key again in order to generate a few keys, and we will confirm that right now. We're currently installing the Vim text editor. Okay, it's ready. We can take a look at the release notes, but right now it actually won't be that interesting. Now we have Git. So how do we run it? Select git bash, and what get is this giant black window. For the sake of making the training recording more comfortable, I increased the font size. It can be adjusted in the options right here. I set the size as 20. The default value, if I remember correctly, is about 8 or 10. So what do we do right now? We have Git installed and we're pretty much all set to start working, but in order to make things pretty, we need to configure it. The first thing I want to do is to generate a few SSH keys. We will need them in order to be able to get authorized on such hosting platforms like GitHub, Bitbucket and so on. All that we need is to run the SSH key again and pass it a few flags. Let's run it. As the type, I'm specifying RSA, one of the encryption algorithms, and as a comment, I'm putting in my email address. Now Git is asking me where to store the keys and offers the default directory, which is users, my username, and .ssh folder. The file title is defined as IDRSA. I will leave it all as is to avoid doing additional stuff later and informing Git about where the keys are stored. So by default, Git will be looking for the keys in this exact location. Here Git is asking me to define the password for my key. We will need this password every time when we will pull data from the server or when we will be sending data back to the server. Because of that, I recommend either not specifying a password if your machine is already secure enough and it has at least screen lock, or defining a really simple one that you will be able to type in 1 second. Here you don't need to come up with something complicated, so I will just specify a password that I will be able to type really quickly. And that's it, the keys are generated. Let's take a look at the file system and see what they look like. Here's the directory where the keys should be stored in the left panel, and here we can see the .ssh directory, and here are our keys. Let's have a look at them. The first key is a public key, has the extension .pub, and the second one is a private key. It doesn't have any extension at all. Let's take a look at the public key. We can see a bunch of really useful information in the end. We have the command that I provided, where I simply type my email. And here's the private key looks like. Using this key, we can add signatures to email, but we will sign commits, or rather Git will be signing commits, and we will just be using that. Some quick advice for you: never ever under any circumstances share the private key with anyone. Using this key that I have on my screen right now, you can forge my commits and send code updates using my name. This is important security related advice. Only ever share the public key. That's what it means for. Sharing the public key isn't a problem. The private key is like signing the document. It must not be shared with anyone, ever. It's like the PIN code on your card, pretty much. Okay, so we generated the SSH keys, and the next step is to load our keys into the system that will be receiving our commits. In this case, I will be using GitHub. I go into the settings, and here I have this wonderful option called SSH and GPG keys. I have my old key already, but I will go ahead and add the key I just generated. So let's call it demo key. So here I need to specify my public key, so we won't be needing the private key pretty much. So I simply select everything, copy, and then insert it right here and click add. That's all. The key is added, meaning that our demo key is right here and we will be using it in our training. Okay, we have one small step left to configure our username and our email. Why do we need this? When we will be creating commits, we will need to sign them and thus defining some type of authorship for them. So here I will select the following commands: git config. I will also take the prefix global to make these settings apply to all my repositories on my laptop. That way, whenever I work with a new repository, I won't need to override this. However, if you are planning to work on different projects under different names, then in this case you won't need to set the global flag. We can see with our parameters what it's gonna look like. Here's my username. Yeah, that's it. Git is ready to roll.